Example 1, we have ourselves an exponential equation with x up in the exponent level. And one thing I want to show you is this. If you have a to a power equals a to a different power, if the bases are the same, then the powers are the same. So if we can get it to this level, we can get the powers to be the same. And that gets x out of the power level, then we have a basic algebra equation, right? Well, 17 and 10 obviously aren't the same number, so we can't right now do that. All right, but what we learned the other day about logarithms is this. The log of some number, let's go x base 10 equals 17. That's not right. Let's do it this way. I did it backwards.
Yeah.
All right, suppose I wrote it this way. If I wrote 10 to the x power is equal to 17. All right, so this is the number I have on this side all by itself, right? And 10 to the x power is equal to 17. I can write that logarithmically as log of 17 base 10 is equal to x. If I want to find the power of 10 to make 17, I do a logarithm, right? Because we learned about logarithms lesson 113. All right. So I want 17 to be 10 to a power, so I can use this rule, right?
Yeah.
All right. So if I want 17 to be 10 to some power, then log of 17 base 10 equals x. Logarithm always equals the power. So if I use my calculator, I get log of 17 base 10. I'm using LOG button because it's base 10. I get 1.2304. So what that tells me is that 17 is approximately equal to 10 to the 1.2304 power. I rounded so it's not exactly the same, but it's close enough for our purposes. Does everybody buy that?
Yeah.
And if we want to test it out to be sure, 10 caret 1.2304 should be about 17. 16.9981 looks pretty close, right? They're about the same. So what I can do now is, instead of writing 17 here, I can write this as 10 to the 1.2304 power. And that's going to equal 10 to the x plus 2 power. All right. So using logarithms in order to change the base to a different base, I get the same base that I want, 10 to some power. And if a to a power equals a to a power, the powers are equal. 10 to a power equals 10 to a power, the powers are equal. 1.2304 should equal x plus 2. And then all we have to do to get x equals is just move the 2 to the other side. 2 minus 1.2304 make the answer negative. We're going to get 0.7696. So negative 0.7696 equals x. Okay. The key to the problem, though, is that x is living in the exponent level. The key to the problem is to be able to use this theorem to get us down to x just in a basic level. So it's a basic algebra statement. Okay, up here it's hard, down here it's easy.